So if you've ever worked in high-end video production, or maybe simulation, you know the nightmare. You need to send a massive 8K data stream across, say, 75, maybe 100 meters.
Yeah, your standard copper cables just choke out after 5 meters if you're lucky.
Exactly. So today, we're doing a deep dive into the engineering solution for that. It's the DVIGear DVI-2875-AOC DisplayPort Active Optical Cable.
And you can tell it's a specialized piece of gear right from the price tag. The 75-meter version we're looking at is $825. This is not consumer tech.
No, not at all. This is infrastructure.
Right. So our mission here is to really understand the technology that lets you send that much data over that distance without a single bit of degradation. We're talking DisplayPort 1.4 HBR3, pushing, a staggering 32.4 gigabits per second.
Okay, let's unpack that speed. 32.4 GBPs. For someone listening, what does that actually unlock visually?
Well, it's the headroom you need for absolute visual fidelity. This cable can handle 4K resolution at a super smooth 120 Hz with 24-bit RGB color.
And that 24-bit color, that's true color, right?
Yeah.
That's essential for professional work.
It's completely non-negotiable for color grading or medical imaging, you name it.
Yeah.
It also supports 8K, though at a more modest 30 Hz. And crucially, it's fully compliant with HDCP 1.4 and 2.2 for all your protected content.
So with performance needs that extreme, traditional copper is just out. But the active optical part is interesting because it's a hybrid design. It's not just fiber.
No, it's not.
It's 4 strands of glass optical fiber for the video, but it's also got 6 thin copper wires. So if fiber is so superior, why include the copper at all?
That is a great question. It's fundamentally required by the DisplayPort standard itself. But you're right, the heavy lifting, the real performance, that comes from the fiber.
And that's where you get the noise immunity.
Exactly. The optical path gives you that huge bandwidth, but it also means it's totally immune to environmental noise. You get this ultra-low RFI and EMI profile, which is vital in sensitive places.
Like server rooms or hospitals.
Think server rooms right next to powerful MRI machines or, government command centers with really strict security needs. It's also why it's TAA compliant for those big institutional buys.
Okay, that low interference profile tells a big story. But the physical design itself tells the story of the installer, the person actually on the job site.
Oh, absolutely. They clearly thought about it.
It's plenum rated, so you can run it through airspaces, and it's surprisingly flexible. We're talking a minimum bend radius of just 35 millimeters.
That flexibility is critical, but the connector design is where the real field engineering shines.
Yeah, me about that.
Well, the cable itself is terminated with these tiny, low-profile mini DisplayPort connectors. They're less than 8 by 11 millimeters.
So you can pull them through a really tight conduit or wall space?
Precisely. It makes the actual pull a breeze. Then, once it's in place, you attach these robust, full-size DisplayPort docking connectors that are included.
And those have a locking pin, right? For security.
The locking pin, yeah, so it's not going anywhere.
Now here's the part that really gets me on the efficiency side. Powering this whole thing. There's no external power brick.
Nope. It just draws what it needs right from the DisplayPort source.
And it's an incredibly small amount of power. It's less than 0.43 watts. That's less than a lot of USB hubs. And they rate this with a mean time between failures of over 150,000 hours.
It's just incredibly dependable.
So to sort of bring this all together, this cable solves the distance problem by leveraging the speed of optical fiber for the really heavy data stream.
Right, for the raw speed.
While still using that little bit of copper for essential power and control, and without sacrificing flexibility or ease of installation.
Which leaves us with a final kind of provocative thought for you to consider. We know the optical fiber flawlessly maintains 32.4 gigabits per second over 75 meters. But the cable still has to perform this critical low-speed electrical handshake using something called the AUX channel.
And that's what handles things like ED and link training, telling the display what to do.
Exactly. It runs at just 1 megabit per second. So the question is, what are the hidden engineering challenges to make sure that tiny electrical signal, which is also powering the active components, performs flawlessly across a 75-meter run of wire?